So what I mean by this enigmatic thing, personalization of diffusion models? Well, I guess a lot of you have already tried and played a bit with those cool models that are available online, where you can just put in your prompt and get some nice generation. But what we would like to have is not only to generate things that were in the training set of those models, but maybe also what we would like is to have the opportunity to use those cool big models in order to generate things that we want, like for example our own images or images of our favorite animals and so on. So we can achieve this with different personalization techniques or adaptation techniques that they have different names, which in general allow us to add those additional things or change the distribution of the model. So why is it even important? I told you already that we can maybe add some funny stuff, like for example generation of ourselves. But if you think about the problem in more general, more generally, you can actually think that see that it's not only about making funny memes, but it's also a very big problem. So what you can see in here is that I took SDXL model, which was trained, I think, last year, and it was trained based on the data that was already 2 years old, or something like that. And if I take this model and I ask about a photo of Robert Lewandowski in a club jersey, we'll get a photo of Robert Lewandowski, but he'll be in a Bayern Munich jersey, which makes sense because at the time of when the data was collected, he was actually still playing in Bayern Munich. As some of you might know, he's no longer playing there. Now he's playing for FC Barcelona. So the problem is that the generation is quite out of date. So what we would like to have is, for example, to adapt this model by updating the knowledge it has. So for example, by changing the way how the model generates Robert Lewandowski, so that now he will appear in FC Barcelona jersey. And how we can do it? Well, the easiest solution that you can think about from that you might have from having some knowledge about basic machine learning is that we can take the same model and retrain it from scratch with the updated data set. But of course, it doesn't make any sense because those big models are trained for days or months on multiple GPUs. So we don't want to do it every time Robert Lewandowski changes club or any other famous player. So what we want to have is to have some ability to fine-tune the model with possibly just limited number of data examples, so that we don't spoil the model in general. We only update this knowledge about the limited part of the model. So speaking more precisely, what we want to do is we want to alter the model posterior distribution so that it's not defined only over the training data that was used for the pre-training of the model, but we also wanted to reflect the updated data set somehow. So, for example, a data set that is extended by additional photos of Robert Lewandowski in FC Barcelona jersey. And this problem is not easy to solve, and there are several problems, or what we can call it research opportunities that we have to tackle when actually doing it. And the first problem I already mentioned a bit, that we want to do it efficiently. So we don't want to train the model from scratch. We want to only update it without spending too much time on this update. Maybe we don't even want to update all of the parameters of the model, so that we can do it faster with possibly less data. And the second thing that is also very important is that we want to be very precise. So when we update the generation of Robert Lewandowski, we don't want to spoil model so that it no longer can generate funny images of cats. This is one important problem, but second thing is that we also don't want it to spoil it, for example, generations of Thomas Müller, so that he also appear in FC Barcelona jersey or something like that. So we somehow want to be very precise and update only the parts of the model that we that we want to tackle. Out of other research opportunities in this general field, there is also the problem of alignment. So when we update the model with some additional data, we want to align the knowledge about the new examples with what we already encoded previously. So for example, we don't want to create another instance of Robert Lewandowski that will be in FC Barcelona jersey, but we want somehow to align the knowledge that model already had about the Robert Lewandowski previously. And last but not least, something that is also very interesting is the problem of combination of those several personalizations. Just imagine that Robert Lewandowski now changes the club once more and goes somewhere else. So we want to take the updated model and we want to update it once more and possibly many times in continual fashion, I would say. This is not an easy task, and it's not so easy to actually solve all of those problems. But there are multiple different techniques that appeared for the last basically 2 years that try to somehow tackle those issues. I don't have time to go into details about every single method that appeared. I just wanted to give you more like an overview of the most important things that happened and give you maybe some hints on where you can just take a closer look and what you can read by yourselves if you are very interested in the topic. Or you can simply ask me after the presentation. I can also give you some more details if you are into it. Okay, so let me start with the very simplest, the simplest concept that we can think about of how we want to generate something that is not easily generated normally generated by the model. And this idea was presented in the paper that is called that introduced something that is called textual inversion. And the idea in here was based on the GAN inversion. I don't know if you're probably you are familiar with GANs. So the idea in there was that we can select randomly select some Gaussian noise, let's say, and we get some generation. But also in GANs we could do the opposite process. So we could take some random Gaussian noise, try to generate something, and compare it with the image that we want to generate. Then based on the error between what was generated and what we want to generate, we can backpropagate the error to the noise and optimize the noise so that at the end we have something like a noise that can generate this particular image that we want. And here the idea is exactly the same, but instead of optimizing noise, we are trying to optimize the embeddings of the text encoder, so that we find something like pseudo words that will result in generation of the sample that we have. In the next paper that I wanted to mention, which is called Dreambooth, and I would say this is something like the baseline for this whole field. The idea was to not only find the tokens that we want to use to generation, but also to change a bit the model. In the previous situation, we didn't touch the model, it was frozen. And here the idea is that we can fine-tune the model using a small number of examples. But in order not to destroy the whole model, what authors proposed was to first find tokens that are not really used by the model, so basically some concatenation of some random characters. And fine-tune the model so that it generates the concept that we want, like for example this dog in here, as a response to this token. Thanks to the fact that we are optimizing those unused tokens, we don't change too much, for example, the cross-attention layers that are not connected to these tokens. But in general, we change also the remaining part of the model. So what authors proposed in here was to add additionally something that they called prior preservation loss, which was basically some rehearsal of examples that the model can generate, alongside with fine-tuning with our input images. So basically what they proposed was to generate a few examples before fine-tuning, let's say, and try to train the model on both images that we want to generate and things that model was able to generate previously. I already told you that the big problem of this adaptation is the efficiency, and well, of course, what we can use in order to speed things up is low-rank adaptation. I guess you are all pretty familiar with LoRa, so I don't want to go into details. What I wanted to just mention was that thanks to the fact that in LoRa we adapt the model in this low-dimensional space, we don't spoil the model too much because we don't update all of the weights thanks to the initialization that we have in LoRa. So this allows us to efficiently fine-tune the model thanks to the fact that we don't have to optimize all of the parameters, only the parameters of the LoRa itself. What I wanted to just mention is that usually LoRa in language models was applied in attention layers, to the attention layers, and this is exactly what we do also for diffusion models, so we also apply it to attention layers. The answer why is that actually a lot of knowledge is stored in the attention layers of the diffusion model, so this is why the LoRa is applied in here. There are several extensions to this basic approach with LoRa. I just wanted to mention two in here. There is some method called zip LoRa, where authors propose to first train one LoRa for object, like for example for this the same dog in here, or and second LoRa that they trained for the particular style, and they propose to combine those two LoRas in order to generate images from with the given concept in a particular style. And they also added some scaling of those two LoRas so that it doesn't break. And similarly to this idea, there is also another paper that is called XLoRa, where authors propose to continually merge several LoRas in order to adapt the model to different objects. If you're interested in this topic, please step by a great paper from the students that I work with. Great poster of the students that I work with. They will be happy to probably share some more details about how we can use this LoRa to personalize diffusion models. Okay, so going back to the fact that what I already mentioned was that we usually apply this LoRa, for example, in diffusion models to the attention layers. And I told you already that this is where most of the knowledge is located in diffusion models. And I was so confident about it, mostly because of the two papers that you can see in here. So in here, what authors did was localization of which parts of the model are encoding, for example, knowledge about some concept like Van Hoff style or something like this. And it turned out that the knowledge in diffusion model is highly localized. It's like there are only, for example, 1-2 layers that encode knowledge about a particular style. So thanks to this, what authors were able to do is to optimize the model in a very efficient way. So they found out that basically there is one layer in text encoder of the stable diffusion model that encodes really a lot of knowledge about particular objects. And since it was only one layer, what they figure out is that we can actually calculate with the closed form formula what should be the new weights of these cross attention layers if we want to adapt the model so that it generates, for example, different president of the United States of America or different British monarch for the same prompt. This left image probably should be updated, but well, the paper is not so. Is already quite old. So this basic concept of using the localization of the knowledge to fine-tune the model was further explored by different approaches, where they combined it in order to fine-tune, for example, models for several concepts, or even combine them in the same photograph with famous Noblist right there, right? And if you like this idea and you want to learn more, please step by the poster of of other brilliant students that I work with. where we showed that when we focus on localization of the neurons or layers of the diffusion models that are especially used for generating textual content on the images, and it's not a lot of neurons, just to let you to spoil a bit. Okay. So this is the end of the first part. The second one is shorter, just so that you know. Because so far I told about the fact that maybe when we want to personalize the model, we want to add something new. But well, personalization not always means that we want to add the new part of the generation, but also of the distribution, but also we want to sometimes remove some part of the generated distribution. And this is what is done in unlearning. So for example, we might have this kind of model like this SDXL in here that can generate harmful content. Like for example, given the prompt of a photo with pizza with pineapple, it really generates something offensive. So what we might want to do is to unlearn the model so that after some operation, it performs in a way that it still generates something meaningful for a given prompt, but it's no longer offensive. It's exactly as if the model was trained with all of the data except for this harmful content. And how we can actually do it? Well, the funny thing is that there are a lot of different methods that boil down to a very similar concept, which is basically fine-tuning in the same way as we do in adding new concept to the data. But this time we can reverse the gradient of the optimization so that we basically maximize the error of reconstructing, for example, this pizza with pineapple. So we basically train the model not to be able to properly generate this content. There are several methods that try to do it with some different in some different ways. But the general idea is more or less the same. There are several challenges in this unlearning concept, unlearning problems that are very interesting. And definitely one very important topic is how wide should be our unlearning. So how precise should we be with the unlearning that we do? And the second important thing is how sure we are that the model won't be able to generate something that was unlearned, because there are already some works that show that even after unlearning, the models still can we can still attack the model and it will generate the harmful content. But if you want to learn more about this, please step by third poster that I'm advertising here. So the poster of Valeria with my great collaborators as well, who is working on unlearning here. Okay, so that's the end. If you have any questions, I will be happy to answer them. If you don't want to ask the old man, you are happy to please go and ask brilliant students that work on those topics. And last but not least, I just wanted to advertise one more thing. That we decided to start some journal reading club about diffusion models that we want to open to everyone. So if you're interested, just stay connected to connect with me on LinkedIn or check my website or drop me an email. I'll be happy to share more information whenever we just set up the date and so on. Yeah, so that's all. Thank you very much.